Hello, everybody. Welcome to my channel. And here, actually, in my last video, I have already shown how to do the top camera calibration. And now I will show how to do the bottom camera calibration. So I will first start the homing. And as you know, here is basically the bottom camera. And then actually what's in here is the advanced calibration. So we need to calibrate the bottom camera with the advanced calibration. Okay, so now it's homed. And then there are a couple of parameters. So first one is the crop width. Here I set it to 600. If you don't want crop, you just put it 0. And the reason for me to crop is basically at some point on the side of the field of view, the nozzle tip will not be able to detect the whale. So therefore, in this case, you can actually crop the field. And then the other one is basically primary calibration Z. So that has to be the same as this one, as here. So make sure it's at the same surface as the primary fiduciary level. So this will be the main surface to work. Um, and then here 4.9. So basically I just lower down like 3 millimeters for it to calibrate second level. So it knows like on different level what was the unit per pixel. And then it can form like a 3D kind of adaptation for different heights. Okay, so now we can do the calibration. So let's go, and then we just click next. So you see it actually lower down the nozzle tips. So we just need to move. Okay, it's automatically switch the camera, but we just put it to all horizontal, then we can see both camera. So here now I just need to do this, and then you see it's already detected the size. But if the size is too small, you can make it bigger, and if it's too big, then you can adjust here. And now I just adjust like this, and then I will let it start. So the process is that it will go through this detection for this level for 7.9 millimeter high, and then afterwards it will go for 4.9 millimeters. So and then after the calibration, we will have some parameter here. So it will detect some of the parameter. So location and unit per pixel. So it will detect the unit per pixel, and then the estimated locating accuracy. And afterwards, there are field of views and also the mounting error. So basically, you can see the camera mounting here. Then it would detect like if there is a little bit tilting and something, so it will adapt for it. And then also here in this graph, you will see the error. So basically on the x-axis, so it's basically on the sequence going through the whole process. And then on the y, it's the error. So basically, you can see along the time it's collecting the values. You shouldn't see like a big deviation. So it should relatively kind of random. So in this case, this looks good. But then we need to also wait for it to finish. So let's just wait for it first, and then do the second level. Now it's finished the calibrating the first level, so now it's going to the second level, and we can actually see here. Okay, we just need to adjust the size a bit, and then to make it stable, and then we can let it do the calibration again. So it will just again looking through this looking through different positions at this level, and then finally capture all the images and then calculate the parameters here. Let's just wait for it. Okay, so now the calibration has been done, and you can see here the calibrating, the result is basically like this. So 16.27 for estimated locating accuracy, and unit per pixel is a 17.8. So it's kind of similar than before, and it's also here it's kind of similar than before. One thing to be noted that now it's actually lowering down the nozzle tip, so you need to actually make it go up to so that it doesn't crash to other place. And then also, so for this, sometimes when the nozzle tip detection, you will see maybe not stable, then you might need to adjust the lighting conditions so that there's no like direct light shining, shooting to the nozzle tip. And also just make sure that when you adjust the size of the detection diameter, then the detection is actually stable. So that means yeah, it's easier to find the nozzle tip so that it doesn't really misdetect. Okay, so basically with this detected, we have finished the bottom camera calibration, and just make sure you do the safe configuration. And then what with the calibration done, we can actually do the for example calibrate of the nozzle tip, so you can see here it's actually able to do the calibration. And if it's not able to detect the center well, then you can also see the debugging here. Usually this range, if you see the heat map here, the range is actually the detection area. And sometimes it could be possible that you set this one to too small, so it's not able to detect it. So you can actually set it to a little bit bigger. And the other thing is the diameter. So if you set the vision diameter to smaller, for example, then it might not be able to detect also where, for example, if I do the apply here, you see it will then detect to the other location, which is also not good because this is too small, so it cannot detect. Um, so what you need to do is just to find the correct size, and then you will do the detection correctly. So yeah, this is basically the let's do yeah, this is basically the how it's how it works. Okay, to make these detections. Okay, let's just give it another try. Okay. Um, so yeah, this is basically the process for calibrating the bottom camera. And then the next video, I will show how to calibrate actually the nozzle tip to the camera offset precisely. So this is also very important to for placing the component onto the board. Yes, okay, then this is it, and then see you next time.